this symbol right here in front of the A. So measure angles A through angles H. This little kind of thing, this just talks about an angle. So it seems pretty straightforward, but not everybody knows that. If I'm looking at these two diagrams, they're polygons. So we're not even talking about triangles yet, but we have triangle or angles A, B, C, and D. And so that's what's just referring to there. If you were to take, if you had a protractor and you were to measure these angles, then we would find that, for example, angle A and angle E are the same. They work out to be 90 degrees and so on and so forth. Okay, so when we're talking about angles, we use this kind of symbol to indicate that we're talking about an angle. On the other hand, when we're talking about side lengths, so it doesn't matter if it's a triangle or if we're talking about a polygon, the lengths of the sides are pretty straightforward. They are just using the two letters of the angles that are connecting them. So for example, sides BC would be this one right here. Side HG would be this one right here. And if you were to take a ruler and measure this, and it's kind of tricky to do on your screen. If you had a textbook like this on paper and you put your ruler just up to the sides here, we would start to notice that there is a similarity between the two shapes. So these are all ratios. So ratio is simply showing two values and how they relate to each other. And if you were to take, and maybe what I'll do is try this. This might be a little bit easier to see. Can you guys see this? These are the same shapes. It's just not the textbook. So if I were to take this side right here, AB, and take this side right here and measure them. So I'm just going to take my ruler. It's going to be different for you because it's going to be based on your screen size. So I've got about 1.8 centimeters and about 3.5 centimeters. So I would write something like this, that the ratio of AB to EH is going to be, what did I say, 1.7 roughly, or 1.8, 1.8 centimeters to 3.5 centimeters. So that's a ratio of the two side lengths. Now, if we were to do that again with it's different color, with a couple of different side lengths, so maybe I would try something like this down here, AD and EF. So I do something like this, the ratio of A to D over E to F, and measure that. This is going to be about 2.5 centimeters and 5 centimeters. So I'm going to put 2.5 centimeters here and 3.5 centimeters there. Now, the textbook asks you a question here. It says, do you find anything interesting in your answers to the first two parts? So using a ruler, approximate the following ratios. So if I go back to here, what am I looking at when I compare this ratio with this ratio? Did I do that right? I don't think I measured that last one right. This is not 5. Apologize for that. This should just be 5 centimeters. So I'm going to erase that. Try that again. There's always a little bit of growing pains with this stuff. So does anybody notice anything about those ratios?
They both equal 0.5 roughly.
Yeah, exactly. So if you were to just put these, like, you know, not sure what your mental math is like, but 1.8 centimeters is roughly half of 3.5. So this ratio works out to be approximately, so we do something that looks like this.
Approximately 2.
Pardon me?
Approximately 2.
Approximately 2.
One
If
half.
you 1/2. If you did it upside down the other way, then yeah. So this would be 1/2, and this one up here would also be 1/2. And so what that tells us, and you would find probably the same thing with the other side lengths. And so that's what it means for something to be similar, for shapes to be similar. They're not the same size, but they have the same proportions, which means that they have the same ratios of side lengths. So this would be true for any shape. So this is some strange sort of polygon, and it would be true for triangles. And so this is what we mean when we say similar. So down here, there's a little definition here. We call two figures similar if one is simply a blown up and possibly rotated or flipped version of the other. So it doesn't matter how the shapes are oriented. They would still be similar because the side lengths are have the same ratios. Okay. So so far so good. Makes sense. Okay. Excellent. So now if we were to keep going, we would find, and so we have that as well, is that the other thing is that the angles would also match up. So once again, if we go back to this shape right here, if I had a protractor and I decided to measure the angle, for example, of angle C, which would be right there, and I measured angle G right there, they would also give us the same angles. And so there's a couple of different ways that you can determine whether some shapes are similar shapes. So the ratios of the side lengths and all of the angles would be the same. So the angles of the shape don't change if the size of the shape is different. So if this one's a lot bigger, the angles don't change from that as well. It's just kind of like if you were to zoom in or zoom out on your phone. Okay. Let's see here. Why don't we try a couple of examples here? Does your textbook, do you guys have a paper like copy of the textbook, or do you have the digital one like mine?
I have both.
You have both? What about Nancy and Melanie? Do you have paper copies of it or just the digital?
I have
I only-
copy. I have the paper copy.
I
Okay.
have paper copy.
You have both. Okay, so you both have paper copies. Do they show the solutions in the exercises?
I think they
There's
do.
an answer book, but like there's no answers in the book.
No.
Okay. All right. Well, that's fine. So why don't we see if we can apply some of this. So let's see if I would really like to make this a bit bigger, but I don't think I can. Okay, so another thing that again, you can always stop me or give me a thumbs up if you already know this, but just like when we are describing an angle and we use that as I was showing you this. So if I want to say angle B, then I would use this sort of symbol. Okay. If we're describing the triangle, then we draw this little triangle in front of it. So in this case here, where it says given that triangle ABC, this little squiggly line, this little tilde line, this is what we use to say that something is similar. Okay. So we're saying that if triangle ABC is similar to triangle YXZ, which of the following statements must be true? So what that means is that the way that it's written is that the letters of the first triangle match the letters of the second triangle. So if I wanted to sketch this out, and let's go and let's just make a new one here. Let's go, actually, you know what? Let's do something like this. I'm gonna copy this and make it a little bit bigger. So if I wanted to sketch these out, what I would do is I would draw a triangle like this. It doesn't really matter what the angles are. If I'm going to say that this is triangle ABC, and let's say I'm going to try to draw a bigger triangle and not make it look too bad. So like this. You guys have to try to believe me that these are similar triangles. If these are similar to each other, then Y has to be down here, X has to be here, and Z has to be here. Okay, does that make sense? So the angles have to match up for a triangle to be sort of following what we're written down here. And so then the question is this statement true? Okay, so this is a ratio, and it's saying that AB over YX is equal to AC over YZ. So take a moment, think about it. Do you think, is this true or not? Do we give it a blue check, or are we going to say no? It's a red X. Anybody have any ideas?
I think it's a check mark
Okay, and can you tell me why you think it's check mark?
because like this one and then like divide by this one
Yeah.
and it was like equals this one divided by this one. And since this is just basically a larger form of it, this divide by this will be the same as this divide this because it's just like the the length thingy is just like just bigger.
Right.
Like for example, if this is like I don't know 2 and 3, and
Yeah.
this is 4 and 6, when you divide them, it's gonna be the same.
Same ratio, just like we saw earlier on, right? In the first
Yeah.
example that we saw. Yeah. And so that's essentially what we're seeing, is that because we've been told that these two triangles are similar, that means that they have to follow those ratios. So exactly. That would mean that the corresponding sides have the same ratios. So we would say, yes, this is a check mark. So we agree. Okay, good. It looks like we're doing pretty well here. Let's see. Let's see. What about AB? Let's see if it's true for this one. So I'll do a new one here so we can keep it on the screen. Is this the same? Is this the same as well? So once again, it's our ABC triangle. So I could have kept the previous one, but same thing if we were to sketch it out. Let's go with, so we got here and here, and then we've got A, B, C, and this was X, Y, Z. Did I label that wrong? Y, X, Z. Ooh, didn't look right. So I think I have these backwards. There we go. So now this is supposed to be Y and this is X. Is this one true? Is this statement true? Yeah, what do you think, Nancy?
Can I like trace them like so this one and then this one and this one.
Yeah, can you change colors? It might be easier with different colors.
I don't think it's true. Cause wait, let me first trace this thing.
Now we got 2 X's so far, so it sounds like Benjamin and maybe Melanie think it's not true.
I don't think it's true too, because like for it to be like for like because like this one and this one like aren't kind of like I don't know how to explain it, but like
I think I
it,
know what you're saying. So
it's
you're
like
you're
this
basically,
one is like basically the same as this one, I think. And
yeah,
then
so
this
it's just
one's
it looks like the
mhm.
ratios are just mismatched here. Now, I should make sure I don't call myself a liar here, but let's see here. Let's just double check because this is AB to XZ, AB to XZ is equal to BC to YX. Now we have to be a little bit careful here. So I'm just going to rewrite this a little bit like this. So we've got the statement is AB over XZ is equal to BC over YX. Now, let me just see here. So I'm just going to make these a little bit different colors here. So we're going to make this one red and make this one red. And that makes this red and that makes this red. Is that right? Oh, no.
But YZ is not the XZ is not that.
XZ.
Oh, XZ.
Yeah. So it says
What do you
AB over XZ is equal to BC over YX, right? So this is why sometimes it's helpful to match the colors because especially if the triangle is sketched out as badly as I've done it. So we've got AB is red and YX is also red. And then I'm going to make this one blue. So XZ is blue and YX, sorry, and then BC is also blue, right? So we got this, right? Is that right? AB over XZ equals BC. Yeah, so the ratio of AB to XZ and the ratio of BC to XY should give us the same ratio. Let me just, oops, I've closed my tabs here. Too many things here open at the same time. So I think you guys are all correct that this is not necessarily true because we don't have the matching sides. So this is not the same ratio. If you even look at this in terms of color, if you made up some numbers like Nancy did in the previous question, we would not get that same ratio. So if you were to even sometimes it's easier to look at this sort of stuff with some real numbers. So if I were to put in, I think you said this is side 2, and we make this side 3, and then this side 4, and this side 6, or even if we went, did something like this, because we're not dealing with that side anymore. Let's say this is a side length of 5. That would make this side length 10 because these are similar triangles. Now, if you were to replace these two ratios with numbers, would it make sense, right? So if AB is 2, then we would have 2 over XZ, which is 10. And then here we've got BC, which is 5. Looks like that. And YX, which is 4. Now, this is pretty obvious that that is not true. So that's one way that you can show that these are, this is not a correct ratio. Okay, so you have to make sure that when you do the ratios, you are doing the corresponding sides, right? So the ratio of AB to YX would be the same as BC to XZ, but not the way that it's been formulated here. Okay. So far, so good. Okay, I see some head nodding. Okay. Let's take a look at, because I think you guys are pretty confident in this stuff, then we can move on to the next section. And then we'll see. Okay, so let's try this one right here. So we'll do a new snip right here. Let's see if you can solve this one for me. Okay, so the question here is, we've got triangle ABC, and it's similar to triangle ADB, and then you've been given some side lengths, so 4 and 9, and the question is, what is AB? So you may want to, you may find it easier to sketch this out and see what it looks like, and then see if you can figure out what is the length of triangle AB. So I'll give you a couple moments here.
Wait, so I drew the triangle like A is here,
Yeah.
B is here, C is here, and then
Mhm.
next triangle I drew A here,
Mm-hmm.
D here, and B here. That's correct, right?
That is correct. Yes.
Okay.
Yeah. So that, because as we just saw in the previous question, if you don't have the triangles labeled correctly, then you're going to get the ratio not work out to be for similar triangles. So if we were to go A, B, C, and this is A, D, B, something like that. So A to C is 4, so that's a 4 there. And A to D is 9. And so we've got something that looks like that. Now, sorry, I'm just gonna move this over here. So we've got AB to AD is going to equal AC to AB. Okay. So I'm just going to make this a little bit smaller. And now this is...
So the hints are in the back, and I think it means that it's the 113th problem that has a selected hint.
Oh, okay.
And it's on the back on page 350.
What? 350?
530. Page 500. Page 530, and then number 113 should have the hint, I think.
We know that the ratio of AB divided by AD, right? So that's a ratio. That's the two corresponding side lengths. And that's going to equal AC. So that's the other side, AC, over AB. Now, I think what would have probably made it a little bit clearer. So I think this is what we can do instead. So maybe this will make the problem a little bit easier for you guys to see, is that you could have these triangles sort of connected. So I think when Nancy, you were showing me that other problem, how like you could have like a couple of triangles connected to each other, they could still be similar triangles. And so what that tells us is that AB here and AB there are likely the same length, the same side length. So there's probably a better way to draw this this diagram out, but we can still figure this out with a little bit of algebra. Do you guys know a little bit of cross multiplying, how to do that with ratios? Have you done that before with fractions?
Yes.
Okay.
So in this scenario, we have AB squared equals AD times AC.
Yes.
Which is AB squared equals 36, so AB equals 6.
Right. So what Benjamin was doing, so for those of you, like, again, I'm just going to assume we're moving at the same pace. So if we move this here and we move this here, we get a new statement that would be AB times AB, and that's going to equal AD times AC. And as Benjamin said, AB times AB is going to be AB squared. And this, we know the two values for. So we know that A to D is 9. So we've got 9 times 4, which is equal to 36. And so therefore, to get AB, we take the square root of 36, which gives us 6. So yeah, so I probably would have been a little bit better off to draw this out with the same two triangles sharing one of the sides. But generally, when you have triangles and you label them using the same letters, then the side lengths would be the same. So this is drawn a little bit bigger than what this one is, but the bottom line is that that side length there and this side length here are the same. Okay, does that make sense? Got our thumbs up. Pretty good. Awesome. Okay. Does anybody have any questions before we move on? Okay, so far so good. Excellent. All right, so let's jump to the next page here. So this is angle similarity. And so again, if we take a look at what this means, is that kind of like the very first thing that we did with the two shapes is that when objects are similar, whether they're triangles, the side lengths will have the same ratios, but also we can see that all of the corresponding angles are going to be equal. And so that is what is being communicated right here. So where these two triangles, so we've got triangle ABC and triangle DEF are similar, then angle A is going to equal angle D, angle B is going to equal angle E, and then by implication, that means that angle C and angle F must also be the same. And this is putting together some rules that we may have learned previously, that the sum of all the angles inside a triangle has to add up to 180 degrees. And so therefore, if A and B are known and D and E are also known, then C and F can be determined by simply subtracting A and B from 180 degrees or subtracting D and E from 180 degrees. And I think that first example right here is no, I can't get rid of that. 6.
Can I go use the restroom?
Yeah, absolutely. So I'll just keep going. We got two triangles, and they have the same measures for the two angles. So we have angle A and B are 50 and 60. We can find the third angle. It says to measure it by using a ruler, but if these are similar triangles, then what would be our missing angles here for angle C or for angle E? if we take 50 and 60, we add them together, we get 110. And if we take that 110 and subtract it from 180 degrees, then we get, oops, we get 110. This is going to be plus angle C. And so therefore 180 degrees subtract 110 degrees is going to give us C. So angle C is going to equal 70 degrees. So that's, I think that's pretty straightforward based on what you guys were doing in the previous questions. I don't think that should give you too much difficulty. Let's see. Oh, problem 5.3. I'm just curious to see if you can come up with a solution to this one. So I'm going to try to make it bigger. Let's try that. So we've got this rectangle, ABCD, and you're asked to find what would be another shape or another figure. We can label it EFGH, and it will have the same angles as ABCD, but it's not going to be similar. So what's something that we can come up with that would match that criteria? We have a shape that's going to be similar. Sorry, not similar. It's going to be matching the criteria of having the same angles. So all of the angles, A, B, C, and D, are right angles. But if we were to take the side lengths and measure the side lengths, the ratios would not be the same. And so we don't have a similar shape. The go. Beautiful looking rectangles. Okay. So far, so good. Okay, so let's see if we can maybe do something a little bit more.
Can I use the washroom?
Yep. We've only got about 10 minutes left, so we'll do that. Okay, so what, let's see if we can do time for maybe one or two more. Let's try problem 5.5. So I'm going to make a new one here. It's going to be over here. And then I'll put it up over here. Okay. So we've got lengths. I don't know if I can remove that. That's on your end. So we've got a diagram here, and there's a couple of things on here that are important. These arrows on here indicate that these lines are parallel, which is important because that allows us to make a few inferences based on the shapes that we see. But the information we've been given here is that the lengths of the diagram are as marked, and it also says that WX, so this line here, WX is parallel to YZ. And then we want to try to figure out what is PY and what is WX. So, actually, that open. So we're trying to solve for PY, which is right here. P is the center, and that's going to be PY. And we're trying to figure out also what is WX. What are the lengths of WX? So we need to figure out those things. So in some cases, this is, we can look at, if I make a bigger version, oh, Nancy went to the bathroom, so I can't get her to erase that. But we have a couple of similar triangles here, and we know that they're similar triangles. Oh, that's bad. Because of the angles inside here. So if I make this a little bit bigger, and oopsie, just take the diagram here. Let's see if I can. So if you take a look at, I see Ben's getting in there already, which is good. So the angle here and the angle here are going to be the same. And this is going to be a property of lines, that angles that are on opposite sides of each other from by two intersecting lines are going to be the same angle. And then we have a few other properties that we can use. And that would be that if this line is, if you can follow this, there's kind of this Z pattern. And I'll see if I can make it maybe in blue. If I trace this line here, like this, that tells me that this angle here and this angle here are also the same. And so now that I have those two angles that are the same, I can put together my relationship between similar triangles. And so what I would do is, you can even just sort of sketch this out like this. This is going to be 5. This is going to be 3. And this angle here is angle X. So stick with black here. And this is vertice W, and this is P. And then we have another triangle. And if I were to kind of imagine taking this and rotating it and making it a little bit bigger, kind of like that. I've taken this and rotated it kind of like in a counterclockwise. So this is P, which means that if you keep rotating around, that this makes this P. I don't know why I made this a B. This should be a P. Like that. And then this would be Z, and then this would be Y. And so now X and Y are similar triangles, or sorry, similar angles, and then W and Z are similar, are the same angle. And so now we can do some ratios of similar triangles. So we can say something like XP over YP is going to equal WP over ZP. And in the question, we're trying to figure out what is PY and what is WX. So if X, P is 3, so that's going to be 3 over, I'm going to change that to PY. And then we know that WP is 5. So we've got a value for that. And then Z to P is 10. So now we can rearrange this, do a little cross multiply once again. So if I move this to the top, move the 5 down to there, we're going to get 3 over 5 equals py over 10. And then move this up here. I'm going to get 30 over 5 equals py. We don't need this here.